All right, moving on to Unit 4. Section 4A is on exponential functions and their graphs, and this video is going to be a really quick recap of those exponent rules from high school. Okay, so our first batch of exponent rules deal with when you add, subtract, and multiply exponents. So we add exponents when we're multiplying like bases. Okay, like if I had x squared times x to the 5th, we would add those exponents and get x to the 7th. We would subtract exponents if we have division of like bases. So if we had t to the 5th over t squared, we would subtract those exponents and get t cubed. And finally, we multiply exponents when you have an exponent to another exponent. All right, so if I had, come back here. If I had p to the 4th and I raised that to the 5th power, we'd multiply those exponents and get p to the 20th power. All right. Next, we'll talk about when you can distribute exponents. And exponents will distribute in two cases. First is exponents distribute over multiplication, and we've used this a bunch of times already this semester. So if we had something like 5x squared, we distribute that exponent. We square the 5, and we square the x. All right, exponents will also distribute over division. All right, so if we had something like 2/3 cubed, we could distribute that cube to the 2. 2 cubed is 8. 3 cubed is 27. Okay, so exponents will distribute over multiplication and division. Where exponents do not distribute is over addition. So this is the one that we try to avoid. It's not true. This is why, like, when we have a plus b squared, we don't do a squared plus b squared. We have to actually FOIL out a plus b times a plus b. Okay, so we do not distribute exponents over addition. All right, next few exponent rules. We've got a to the 0 is equal to 1. Anything to the 0 is equal to 1. X to the 0 is equal to 1. 5 to the 0 is equal to 1. Negative 1,000 all to the 0 is equal to 1. Anything other than 0 to the 0 is equal to 1. And 0 to the 0 I will leave to your calculus professor to talk about. But for us, any other number raised to the 0 is going to be equal to 1. All right, our last batch of exponent rules are maybe ones that you haven't seen before, depending upon what your math background was in high school. The first one is negative exponents. So a negative exponent means that the thing with the exponent really wants to be on the opposite side of a fraction. Okay, so if I gave you 2 to the negative 3rd, that means that 2 would really like to be down in the denominator with a positive exponent. So that would be equal to 1 over 8. Okay, it doesn't really matter what it is. X to the minus 2. And let's say I had like 5 times x to the minus 2. Okay, that means that the x to the minus 2 wants to be in the denominator. The 5, though, has a positive exponent, a 5 to the 1, so the 5 would stay up top, and only the x squared would move down with a positive exponent. And even if you had, like, a negative exponent down in the denominator, this means that it would like to move to the other side of the fraction. It would move up as 3y to the positive 4. Okay, so negative exponent means that it belongs on the other side of the fraction, wherever it is. All right, and then the other kinds of exponents that might be new to you are the rational exponents, the fractional exponents. Okay, so this is like, for example, if I had 25 to the 1/2, okay, that n tells you that it's a radical, and it tells you what kind of radical it is. So since I have a 2, that means that this is a square root of 25. All right, now we don't normally write the 2 there when it's a square root, so this is just square root 25, which is 5. All right, and then also if we had, if you had the cube root of 8, if you want to go the other way, we could write that as 8 to the 1/3. Okay, so this is a way you can get a calculator to do other kinds of roots other than a square root, is to use a fractional exponent. All right, and then we kind of expand that with this rule. So if instead of having in the last one our rule was a to the 1/n, was the nth root of a. Okay, if instead of a 1 up top here, you've got an m, that m goes inside as the exponent on the a. Right? So if you had, let's see, if you had like 4 to the 3/2, that would be the square root of 4 cubed. Okay, and again, we don't normally write that square there. 4 cubed is 64, so this would be the square root of 64, which we know is 8. All right, so again, those rational exponents might not be very familiar to you, but we'll be using them a lot in this chapter. All right, so that was it, just a review of exponent rules. In the next video, I'll introduce what an exponential function is.